Today we're going to do lesson 2.5, solving compound inequalities. Give me a good definition or explanation of the word compound. Two. Okay, more than one. So if you look at the essential question for today, it says, how can you use inequalities to describe intervals on the real number line? So the first fill in the blank I have for you on today's notes is compound inequalities. All right, what is a compound inequality? It consists of two inequalities connected by and or. Okay, so fill in the blanks. We're going to have two different types of compound inequalities. One that is called an and one that has an or. All right, so here's the difference between the two. The and, it is written with the variable in the middle, and the graph is the intersection of both sets of solutions. So fill in those blanks, and then I want you to highlight the word and. I want you to highlight where it says variable in the middle, and I want you to highlight intersection. Now, I'm going to try to make this as simple as I can. All right, you can see from my example right here, the variable is in the middle. All right, the variable is in the middle. You have x is greater than 0, because remember, we read inequality starting with the variable. So we have x is greater than 0 and x is less than or equal to 4. Okay, so you see how the variable is in the middle. Now let's talk about what the graph is going to look like. We're going to graph both of those numbers on the same number line, and we are going to draw arrows just like we've been doing. But here's what you're going to notice about these and inequalities. The graphs, okay, or the arrows are going to intersect or meet in the middle. Now, hopefully, that's really easy for you to remember. If the variable's in the middle, then if you graph correctly, the graph should actually meet in the middle, okay? Intersect in the middle. Now, the second type of compound inequality is an or. This is written as two separate inequalities. Two separate inequalities. And the graph is the union of both sets of solutions. So I want you to highlight or, I want you to highlight two separate inequalities, and I want you to highlight union. Now let's talk about this one. It's two separate inequalities. You can see from the example I gave you, x is less than -1 or x is greater than 2. Okay, so the word or is always going to be there in your final answer. So if we were to graph this, we would again graph both numbers on the same number line. This time, the arrows would go in opposite directions. So again, hopefully this is easy for you to remember. All right, it's two separate inequalities, and the graphs are going in two opposite directions. Okay, now let's practice writing some compound inequalities. It says write an inequality that represents the statement and then graph the inequality. So if you look at letter A, we have to decide first, is this an and or is this an or? Because an and inequality has the variable where? In the middle. Okay, so let's read letter A. It says a number D is more than 0 and less than 10. So is this an and or an or problem? And. I mean, it's right there in the sentence. It says and. So that means my variable is going to go where? In the middle. So the variable they've given us is D. So we're going to go ahead and write down D. Now here's the next dilemma. I've got two numbers in this problem. I've got a 0 and I've got a 10. One of them is going to go to the left and one of them is going to go to the right. So if you understand number lines, this is going to be a real easy question for you. Which number goes further to the left on a number line? The smaller number or the bigger number? Smaller. The further left you go on a number line, the smaller your numbers get. So of your two numbers, 0 and 10, which one is smaller? 0. So 0 is going to go to the left of your D and 10 is going to go to the right. And you notice I've left a space because I've got to insert my symbols. Now the question is, which symbols am I using? This says a number D is more than 0. So what symbol represents more than? Which one? Greater than or less than? Greater than, right? More than is greater than. So here's where you got to be careful though. We're supposed to read from the variable. So make sure that when you write this down, it still reads D is greater than 0. So it might look like to you, you put down a less than symbol, But because we read from the variable, that is D is greater than 0. Now, it says and less than 10. So what obvious symbol are we using for the other inequality? Less than. It says less than 10, so D is less than 10. So there is your compound inequality. And again, we knew to put the variable in the middle because this was an and problem. All right, now, number line. This should also be pretty simple. We're going to put the two numbers on the number line. The only question is which one goes to the left and which one goes to the right. So which number is smaller? 0. So 0 is going on the left and 10 is going on the right. Now we talk about the circles. All right, the circle on 0, is it going to be open or is it going to be closed? Open. How do you know it's going to be open? Good, it's just greater than. So we know the circle is open. And what about 10? Is the circle open or closed? Open. Again, open because it's just less than. All right, so we've got our open circles. Now, based on our answer, we've said D is greater than 0. So when I start at 0, what direction should my arrow be going? If I'm representing numbers greater than 0? To the right. So I draw that arrow, and I'm going to go ahead and put an arrowhead on it. But now I got to go to the 10, okay? D is less than 10, so if I start at the number 10, what direction should that arrow be going? Left, for less than, right? So I'm going to take the arrowhead off, and then I'm going to start that second arrow, and look what happens. There is your intersection in the middle, and that's exactly what should happen. The variable is in the middle, so when I graph, if I've graphed correctly, the two arrows should meet in the middle. Okay, the two graphs should meet in the middle. Now letter B. A number A is fewer than -6 or no less than -3. Question, and or? Or. It clearly says in the word problem, or. So, how many inequalities are we going to be writing? Two separate inequalities. We learned that from the definition. The or compound inequalities are two separate inequalities. All right, so a number A is fewer than -6. What's that going to look like? A is less than -6. Okay, and it's just less than because it says fewer than. All right, A is less than -6. Now, the key here is the word or has to be in our answer. So we're going to put that word or down. And then it says or no less than -3. So what is the second inequality going to look like? All right, we're going to do A again. That's good. Good. No less than. So if it's no less than -3, we know it's going to be greater than. Is it just greater than, or is it greater than or equal to? Good. It says no less than. So it could be -3, but we know it's going to be -3 or larger. So A is greater than or equal to -3. And there is the answer that you're going to box in. But again, the or compound inequalities have to have the word or in the middle. Now let's go on to example number 2. We're supposed to solve the inequality and we're supposed to graph the solution. So I want you to tell me, when you look at letter A, are you looking at an and problem or an or problem? All right, we said and. Why and? How do you know it's an and problem? No, Kayla? The variable's in the middle. That's how you know. All right? So I would make the note above letter A. I would put and. Okay? Let yourself know it is an and problem. And it's because the variable is in the middle. So nothing's going to change for us when we're trying to isolate the variable. All right? We're still trying to get m by itself, which means I have to move what number? 4. All right? And how am I going to move it? I'm going to subtract it. Now here's the mistake that gets made. No one usually struggles with subtracting from the middle and subtracting from the right. But guys, there is a third part of this problem. There is a left side as well. So you have to remember with these compound inequalities, I'm actually moving numbers at 3 different spots. So -4 in the middle, -4 from the right, and I've got to do -4 from the left. So there's 3 different places I'm going to be adding, subtracting, multiplying, or dividing these numbers. All right, now let's do the math. 5 minus 4 is what? 1. 1. I bring down less than or equal to. I bring down the m because the 4's cancel. And I bring down less than, what's 10 minus 4? 6. Is m isolated?
Yeah.
Absolutely. So there is my answer. Except, what's the last question I'm supposed to ask myself before I box these in? Do I flip the sign? And what's the answer to that question? No. Okay, we didn't multiply or divide by a negative number. So we leave the signs the same and we graph. What number's going furthest left on this number line? And what number's going further right?
6.
All right, the circle on 1 should be what? Closed. Because it's or equal to. And the circle on 6 should be what? Open. Because it's just less than. Now, the arrow. Michaela, the arrow from number 1 should be going what direction? All right, now be careful. Remember, we read from the variable. So if I read from the m, it actually reads m is greater than or equal to 1. So what direction should my arrow go? Okay, from 1, my arrow should be going to the right. All right, m is what then 6? Less than. So if I start at 6, KK, what direction should my arrow be going from 6?
This way. Right.
Right is this way.
Oh, I meant left.
Left. Okay, I was like, m is less than 6. Less than is left on a number line. So I'm going to remove the arrow because when I go left from 6, again, I have an intersection in the middle. And that's what should happen. Now, here's what I don't want you to do. I don't want you to assume that the graph is going to meet in the middle. You say, oh, well, Ms. Johnson taught me this is an and, the variable's in the middle, so the graph is in the middle. Because here's what you do. If you draw your circles and just automatically connect them in the middle, what if you've written your answer wrong? Okay? So that's why follow along with what you have written down, and that way if your graph looks funny, you'll know you've made a mistake in your answer. All right? So don't just assume, oh, the variable's in the middle, so I'm going to put the numbers, put the circles, and I'm going to go ahead and connect them. Okay? Follow what you've written, because if you've made a mistake, then your graph would go in opposite directions and you'd know it was wrong. All right? Let's look at letter B. Now, is this an and or an or problem? An or problem. I mean, very clearly we see or. Now, this is what I would suggest with the or problems. I do this on quizzes and I do it on tests and I do it right now. Circle the word or highlight the word or, because this is what I saw last year on test, okay? I saw people try to make this one big problem. It's almost like they use the or as their two sides of the equation. It was really strange, okay? But you need to recognize that or, the word or, is separating these into two completely different problems. So let's work the problem on the left first. The 4c plus 3 is less than or equal to negative 5, all right? How do we solve this inequality? What do we do first? Subtract 3, all right? We learned yesterday, don't call me after midnight. If we followed that, we'd get all the way down to add or subtract. So we're going to subtract 3 from both sides. So we have 4c is less than or equal to, what's negative 5 minus 3? Negative 8. Awesome. How do we finish this problem? Divide both sides by 4. So c is less than or equal to, what's negative 8 divided by 4? Negative 2. Now, before we box it in, the question, do I need to flip the sign? No, okay? And I'm glad you said no. Occasionally people get tripped up. They're like, well, the answer's negative, so yes, I have to flip the sign. No, it has nothing to do with your answer and everything to do with the last step. You divided both sides by a positive number, so you leave the sign alone. All right, now, don't box anything in yet because we're not finished. We have a second inequality that we have to solve. On the other side of the word or, we have c minus 8 is greater than negative 1. So how do I solve this inequality? I add 8 to both sides. Perfect. So c is greater than what? 7. Now, question, do I need to flip the sign?
No.
Definitely not, because we added, we didn't even multiply or divide in this problem. So here's what I would do next. Drop the word or down and go ahead and drop the c is greater than 7 down. That way you can box in your answer and it looks like it should. So c is less than or equal to 2, or c is greater than 7. Now let's graph it. Which number goes further left? And which number goes further right? 7. All right, Taylin, my circle on negative 2 should be what? Closed, because it's or equal to. And the circle on 7 should be, Talon? Open, because it's just greater than. All right, Morgan, the arrow from -2 should go what direction?
To the right. I mean, to the left.
To the left. C is less than -2. Less than is to the left. All right, and then C is greater than 7. So, Coy, the arrow from 7 should be going what direction?
Right.
To the right. So do you see? It's an or problem. There are 2 separate inequalities, and your graph has 2 arrows going in opposite directions. Again, don't assume. Don't say, oh, it's an or problem, so they're automatically. I had a girl in first hour. She graphed based on her answer, and one of her arrows were going the same direction, which caused her to go back and fix. She realized her answer was wrong, okay? Because she graphed her answer. So graph your answer. Don't just assume, oh, it's an or problem, so I'm going to draw my arrows in opposite directions. You might have your final answer written wrong. All right? All right, first things first on letter C. Do we have an and or an or problem?
And.
This is an and problem. So again, if you want to make yourself that note until you are sure you understand it. Why is this an and problem? The variable is in the middle, all right? So we see that the variable in the middle is the k. So what do we need to move first so that k is by itself? The 5. And how do we move it? We're going to add 5. Now remember, we add it in the middle, we add it to the right, and we add it to the left. How many of you remembered to add it to the left as well? All right, if you didn't, go back and fix it. So -3 plus 5 is 2. Less than 2k comes down because the 5's cancel, which is less than 7 plus 5, which is what? 12. All right. We're not done, though, because this time k is still not isolated. How do I isolate the k? Divide everything by 2. So again, I divide in the middle, I divide to the right, and I divide to the left. What is 2 divided by 2? And typically, I don't have to bring the 1 down, but when there's nothing else over there, I have to. So 1 is less than. Now the 2's here also equal 1, but I can just bring the k down. It's not necessary to have a 1 in front of the k. And that is also less than, what's 12 divided by 2? 6. So the last question, what's the last question we ask? Do I flip the sign? So what's the answer to that question? No, we divided by a positive number, so flipping the sign is not necessary. All right? So now we graph. Which numbers to the left and which numbers to the right? The circles on both of these will be what? Open. The arrow from 1 is, Kiana, going in what direction? Good. If we read from k, k is greater than 1, so greater is to the right. All right, and then from 6, Michaela, arrows right, going right or left? Left. K is less than 6, so I take off the arrowhead because when I draw an arrow from the left of 6, I get that intersection in the middle. Let's look at letter D. Is this an and or an or problem? Or. Again, I would circle that word or, highlight it, make it stand out so that you clearly see there are 2 separate inequalities. If we solve the first one, 2p plus 1 is less than -7, what do we do first? We move the 1 by subtracting it, all right? So we have 2p is less than what? -8. All right, how do we finish this one? Divide both sides by 2. So p is less than what? -4. What's the last question we ask? Do I flip the sign? Do we flip the sign here? No, we divide it again by a positive number. All right, we can go ahead and bring down the or if we want so we don't forget. But now let's work the second inequality. The 3 minus 2p is less than or equal to 1. What did you move first?
3.
How did you move it? We subtract 3 from both sides. Awesome. So -2p is less than or equal to what? -2. And then how did you finish this one? Divide both sides by -2. So p is less than or equal to what? 1. Now the last question we ask. Do we need to flip the sign? What's the answer? Yes. All right. Yes, we do. We divided both sides by a negative number. So yes, we do. So p is greater than or equal to 1 is going to be our final answer. And we already have the or between the 2 answers, so we can box it in. Now, on the number line, which number goes further left?
-4.
All right, and which number goes further right?
1.
All right, circle on -4. Open, and circle on circle on 1 should be closed. Arrow from -4 should be going which direction? P is less than -4. Less is left. And P is greater than or equal to 1. So what direction from 1? To the right. Now this is the problem I was talking about earlier. All right. If you graphed based on what you wrote, all right, I had a girl this morning who forgot to flip the sign. So when she graphed based off of her answer, her second arrow from 1 was also going to the left, and she knew something was wrong. All right. So again, I'm going to say graph your answer and then let what you graph guide whether or not your answer is correct. All right. That is lesson 2.5.